Hello, and welcome to this video and hopefully the start of a series in which I solve some Sudoku puzzles. I figure I do one of these most days anyway, and so if I did it live and recorded it, that would provide some discipline to me, and if it brings anyone joy, all the better. So I went on to Logic Masters Germany this morning and I picked out a puzzle. It was one of the newest puzzles that had been posted today. Even as of right now, I think it is maybe the third newest puzzle there. It's by a setter that I particularly like, named Abdul the Killer, and it's rated 3 stars, which is out of 5, which means hopefully we'll be able to solve it in a reasonable amount of time. So let's just get into it. So it has a lot of rules, although none of them are particularly complicated. So probably the most complicated and kind of richest rule that we're going to have here is this shading rule. So you'll notice that the board is divided into 2 types of cells, gray shaded cells and white unshaded cells. Now the difference between these is if I look at a cell and I look at the neighbors adjacent to it, if it's shaded within its box. So let's actually pick this cell because it's next to another box and it's shaded. So if I look at this cell here in box 3, then I can look at its neighbors next to it. So in that case, that's these 3 cells next to it. Since this cell is shaded, one of its neighbors is going to be 1 less than itself. So for example, if this were an 8, oops, in the colors, then that would mean that one of these would have to be a 7. Right? Now, that doesn't apply over here, right? So I'm only looking within the box. Similarly, if I look over here, let's say this is an 8, because this is unshaded, what that tells me is that none of these is a 7. So the 7 in fact would have to be one of these 5 cells. I could have a 7 here, right? So a 7 there would be fine because they're not in the same box. So the shading rule only looks within the same box. So that's the first rule. The second rule is an anti-knight constraint. Anti-knight just means that if 2 cells are a knight's move in chess, so from here, that would be any of these 4. So a knight's move is 2 away in one direction and 1 in another. So 2 left and down, 2 down and right. Those all have to be, this has to be different from any of the other 4 that are a knight's move away. Now these 2, they already have to be sort of in the same box, but these 2, right, that's a new kind of restriction here from the anti-knight constraint. Algebra, each letter and the represent a different digit. So I've got these letters here, and they represent something. So this G is going to have to be the same digit as this G here. And if I'm reading this right, that means that this also has to be different from this O. So these 2 G's, let's say these were 2, right? This O could not be a 2 because they have to be different digits. Whereas if it were a 3, then this O would also have to be a 3. And the same thing with the. So these those are all the same digit. And then the last rule is magic square. So this says that the central cells, that's these 9 cells here in the middle of each box, form a classic 3 by 3 magic square containing the digits 1 to 9, each row, column, and diagonal summing to 15. Okay, so what that means is that this is essentially its own region with the cells with the numbers 1 to 9, and this row, right, will sum to 15, this row will sum to 15, this row will sum to, this diagonal and this diagonal, right, will sum to 15, this column will sum to 15, etc. So a typical magic square. And then standard Sudoku rules apply. So let's get into it. I'm immediately drawn to this magic square constraint. It's actually quite restrictive for 2 reasons. One is interact with the shading, and I think that's actually more interesting, so we'll start there. So with this magic square, I'm looking at every central square. And central squares in the shading puzzle are interesting for 2 reasons. The kind of more intuitive reason it's interesting is, well, let's take a look at this cell here, and I put a number into it. Let's say it's 3. Well, almost certainly that's going to be shaded because this cell is adjacent to every other cell in the box. And so the 2, which is 1 less than the 3, has to be adjacent to it somewhere. So pretty much always this is going to be shaded. The only time it won't be shaded is if there's no digit less than it, right? And the only time that's going to happen is 1. So if I look at these, again, central squares, there's only 1 that is not shaded, which is this one here. So that has to be a 1. The other reason that's interesting is that because every other cell in the box touches this, then the number one higher than that cell is also going to be shaded. So from here, because this is a 1, I know that the 2 has to be in, I'm not going to actually mark this, but just for now, the 2 has to be in one of those shaded cells. It can't be in the unshaded cells because then it would be adjacent to the 1 and not shaded, which would break the rules. So that's another way those central boxes are very important. So going back to this magic square idea, now basically there's only one magic square in a 3x3 kind of standard digits 1 to 9. You can rotate it and reflect it different ways, but it's always basically the same. You're always going to have a 5 in the middle. And I can show that to you fairly easily. So because every single digit 1 to 9 is accounted for in this magic square, then if I put anything that's not a 5, I'm going to run into a problem. So let's say I pick a number less than 5. Let's say I pick a 4, right? Now, what's wrong with a 4? The reason this 4 can't work, there's lots of reasons, but I think the most intuitive way to explain why this 4 couldn't work is, well, this 4 is going to be next to, in the magic square sense, a 1 somewhere, right? Because one of these digits is going to be a 1. In this case, we'll put it here. It doesn't matter where it goes. It will be somewhere. Now, if I have the 4 and the 1, I have to then add a third digit, which will get us to 15. Well, 1 and 4 is 5, which would mean I need to put a 10 across from the 1 to get up to 15. And since I only have the digits 1 to 9, that is not going to work. So I can't put a 10 here. If I make this even lower, it just gets worse, and now I need an 11, right? So the lower it goes, the worse it gets. Now let's say I pick a number more than 5, I'm going to have the opposite problem. Right now, instead of looking at what happens when I have the 1, what if I put the 9 somewhere? And I'll put it here, but it really doesn't matter where you put it. 9 and 6 is already 15. And so what do I put in the next cell over? It has to be 0, or if this goes up to say 8, or even less than 0. And that's not going to work because I only did just 1 to 9. So this has to be a 5, right? So that has to be a 5. And now I can look at this column, right, in this magic square. That has to sum to 15. 1 and 5 is 6. That has to be 9. And now, as soon as I placed the 1, I kind of knew I know we're in one of two kind of worlds here. And so I could, in theory, mark these up with the 2 digits it could be. I might do that if I run out of ideas, but I'm not going to, just because I don't think it's going to be that useful, and I want to keep the board as clean as I can to try to look at the actual clues given. I think they're going to lead me in the right direction faster than my pencil marks. But the one I will mark is this one, because it's quite clear to me that has to be a 2-4 pair. Why? Because this this row is going to have to add up to 15. I already have 9, so those 2 have to add up to 6. The 1 and the 5 are already used, so that has to be a 2-4 pair. So that's what comes to mind immediately. Again, I could fill these in with 2-digit pairs, but I don't think that's going to be super useful. So what else can I do here? Let's see. Well, let's look at, so the things I'm immediately drawn to are these letter pairs. By that I mean letters that appear more than once. So this G, right, there are 2 of them, and because they're across from each other, and I look at box 4, then that G has to be one of these, because the anti-night constraint actually can't be there in the middle, because that's a nice move away from this G. So I've got a G in this left column here in box 5. Similarly, right, I can look here with box D. That's in one of, the D is going to be in one of those cells. That's not so interesting, I guess. There's 3 thes. So the is going to be in one of those 2 in box 4. It's going to be in one of these 2 here. I guess that's not so interesting yet either. So we'll move away from that. Let's go to the shading constraint. So this is usually pretty, it doesn't seem like it's doing that much, but it's actually quite restrictive. So for example here, I know that the 2 has to be in one of these spots. But more importantly, if I look at the number 1, 1 is kind of the most restrictive number here, because 1 can only go in an unshaded cell. I can't put 1 in a shaded cell because there's no digit between 1 and 9 that is less than 1. So again, looking right here in box 5, 1 is not in this middle column. It's not in the left column because they're all shaded. It's not in those 2 cells. It can only go here. Does that get us anywhere else? We know that a 1 has to be in one of those cells. Do I get anything else from this? Maybe not. 1 has to be in one of these. We'll mark it, although it's not too exciting. But it might be exciting for 2. So let's move on to 2's for a second. So where can 2's go? Where can 2's go in box 5? Right? So where can 2's go in box 5? So the reason I'm drawn to box 5 is there's a very kind of interesting shading pattern. What's interesting about it is that each column, after I've filled in the numbers that I have, each column is either all shaded or all unshaded. And that can be interesting because it really can force some separation. So what I mean by that is, let's think about the number 2. Where can 2 go in this box? Well, it can't go in the left column because those are all shaded and they're not adjacent to 1. So 2 can't go here. 2 can't go in the middle column because they're unshaded and they are adjacent to 1. So I can't have a 2 here. And so the 2 has to go in one of those 2 spots. And that's going to chain actually into the 3's, because if I think about now, where does 3 go in this box? Well, again, 3 can't go in the left column because it's shaded and not adjacent to wherever the 2 is. It can't go here because let's say I put the 3 in the top and the 2 will have to go in the bottom. And now this 3 is not adjacent to the 2 but shaded, so that won't work. So 3 is going to have to go into one of these middle column. And importantly, I can't do something like 3, 2 because then the 3 will be unshaded next to the 2. So if the top one is the 3, then the bottom has to be the 2 and vice versa. So we're going to end up with a cool little interesting pattern like this. Okay. Where does the 1 go in column 7? Right, so it has to go in an unshaded cell, so that's these 3. It can't be the Y because that's a nice move from this one. So I'm in one of those 2 spots. Where does the 1 go? Here. Okay, so interestingly, where does the 1 go in the letters? So where does the 1 go in row 3, right? Well, it's not in any of these shaded cells. It's not in these 2 cells because of these 1's. So 1 has to be, over here. It can't be the B because that's shaded. It can't be the, I'm not just looking at here, but because there's a the over here that's shaded. So if this were 1, then this would have to be 1. So the 1 is either the A or the D, and it's not the D because of this D, so that's not 1. That is 1, and A is 1. Okay, now we're getting somewhere, I think. So now I've got a lot of the 1's taken care of. 1 is going to be in one of these. 1 is going to be, that's not too useful, but I'll mark it anyway. Okay. Does that have to do with 2? So where does 2 go in this box? It could go here, or here, or here, or here. Okay. Not so useful, actually. Actually, it can't go there, interestingly. The 2 can't go there because if this were 2, this would be 2, and it's... oh, no, actually, that's fine. No, so the 2 could go there. Okay, so where is the 2? I'm not sure. Maybe we'll figure that out in a bit. Well, maybe the 2 over here. So where does the 2 in box 2? That is interesting, actually, because the 2 is in one of those 2 spots. So why is that? Well, 2 can't go in either of those cells because they're adjacent to the 1 and unshaded. Can't go here because of this pencil mark. I know the 2 in column 6 is in box 5, so it can't be here or here or here. And so that leaves me in one of those 2 spots. So the 2 is there. And then, okay, now we're getting somewhere. The 2 here in box 3 has to be in one of these cells. Why does it have to be in one of those cells? Well, we can't be in the top row because of this set of 2's. It can't be in the bottom row because they're not adjacent to anywhere a 1 could be, and they're shaded. So you can't have a 2 in any of those. So 2 is here, which means 2 is in one of these, and that gets us our 2-4 distinction separated. Okay, that's huge. So now we have this 2-4 separation, and now I can fill in the rest of the magic square. So let's look diagonally here. 2, 5 is 7, and so to get to 15, that needs to be 8. 8 and 4 is 12. To make that 15, I need that's a 3. 3, 5, and 8, that's got to be 7. 8 and 1 is 9, that has to be 6. And if you look the other ways, right, they all work, it's all 15. So that is our magic square. Cool. So the magic square is done. And now that's going to give us a lot more information. So much information that I'm having trouble thinking about where to look first. So let's go to that idea before with the central squares. The digit 1 higher is going to have to be, in that box, is going to have to be shaded. So here, my 2 is going to be one of these. That's not so exciting. Although actually it's not the G, because there's a G here, and that's not a 2. So that's somewhat restricted. The 4 is going to be one of those cells. I didn't put a 4 here because it's a nice move away from this 4. The 9 could be, so there's only 3. Normally I'd pencil mark if 3, but they're all in different rows and columns, so it's one of the least useful 3 squares it could be. What about 7s? 7s are in one of those. That's not so exciting. 3s are in one of those. That's not so exciting. Okay, so where does the 2 go? Here. It could go in any of these spots. That's not so exciting. I was hoping it couldn't go here. Is there a reason 2 can't go here? What if, no, I think that's fine. Okay, so what is next? What is next? Well, I have a lot of digits on the board now, and now I'm thinking about, so because these letters are all unique, actually how many are there? So let's count how many of these that there are, because if there are 9, which I'm hoping there will be, and it kind of looks like there is, then each digit is going to have to be one of the letters. So the, B-A-D, that's 4. The is a repeat. G-O-D is 3 more, so that's 7. The is a repeat. G is a repeat. Wait, did I do something wrong? Oh, D is a repeat. Sorry. Let's start that over. The, B-A-D, is 4. The, D is a repeat. O is 5. G is 6. G is a repeat. The is a repeat. Yeah, 7, 8, 9. So there are 9 different letters here, which means every digit is going to have to be one of the different letters. So if I think about, maybe I think like, where does the 4 go, for example? The 4 is going to have to be, either this O or the U, L, or Y. Why can't it be D? Because that's a nice move away. Why can't it be G? So I can think about things like that. And so I'm going to go through each digit and hopefully find something. So the 4, that was a lot of different places. The 3, I guess the 3 could be D. The 3 could be U, G, L, or Y, or O. Yeah, okay, that's not so interesting. 2, what could the 2 be? Well, actually, so the 2 is either the or B, actually. So 2 can't be D, for example. It can't be Y. It can't be any of these. Does that give me anything interesting? Like, where does 2 go in row? Where does 2 go in row 7? It's one of those spots. That's not so interesting. Okay, about 5. What can 5 be? 5 could be, can't be the, actually. It could be B. It could be Y. Or it could be O. That's not so interesting. So 5 is boy. Where does 6 go? 6 could be the, it could be UG, can't be L or Y, or O, or it could be D. Okay, that's not so interesting. Maybe this is not the right way, but let's just to complete it, let's look at 7s. I don't see an obvious thing that 7 has to be. 8s, same problem. Actually, 8's no, not so constrained. 9s, 9s are a little better. 9 could be B, U or L or Y. No, never mind. Okay, so let's try the other way. Let's look at the letters and see what digits they could be. So I'm drawn to D because it's kind of central and next to a lot of digits. So D can't be 1, it can't be 2, it could be 3, can't be 4 or 5 because of Knight's move. It could be 6, can't be 7, this D can't be 7. Oh, this D can't be 3 either. Because of this D, right? So these are the same. There could be 6, there could be 8. They can't be 9 because that's next to this one. So that's actually pretty good. So D is either 6 or 8. And I wonder if I can figure out yes. Okay. This is kind of hard. I'm not sure this is the intended thing, but this can't be 8. So let's say that these Ds were 8. Why is that a problem? Well, let's look at box 9. Where does 8 go in box 9? Well, it can't be Y. Why can't it be Y? Because it's already D, and all the letters are unique. It can't be here or here because of either Knight's move or normal Sudoku. Because of this 8, it can't be anywhere here. And so I have to have an 8 in one of those two cells, right? Now where does, now we have to turn the crank once more. Where does 8 go in box 8? U, G, and L. It has to go in one of those spots, but it can't be U, G, or L because it's already D. So D cannot be 8. In terms of how I saw that, again, I was just trying to think, well, what would happen if it were 6 or 8? I kind of randomly chose 8 first. I don't know why. And by choosing 8, I looked up where the 8s meet. Here's an 8, here's an 8, and thought about what would happen and saw that it couldn't work. So these are 6. And that's going to give me some information about 5s, although not too much information. Maybe it's going to be more about 6s, actually. So one of these is going to be 6. 6 is going to be any of those. That's not so interesting. 6 is going to be one of these. Almost interesting. Okay, so here 6 is going to be one of those two because it can't be a letter, and it's not going to be here because of this 6. Okay, that's great, actually, because that's 6 and that's 2. So that's going to help us hopefully disambiguate these. Yes, and now 2 is the. That's huge. So 2 is the. So this the is also 2. 2 is going to be in one of these. I don't know which one, but not this one. And because 2 now is shaded, that has to be 1. Ah, that's cool. I like that. And that means that's not 1, so the 1 is up here. And the 1 is not here, so 1 is here. So only ones I have left are this kind of pair here. Okay, so now where does 2 go in box 4? It has to go across from row 1. So now I have a 1-2 pair in box 4, which is good. I have that 1-2 pair. And that's just normal Sudoku. Now I'm looking at, now I'm just trying to do basic Sudoku, so I'm looking for places where there are lots of digits filled in. So I'm looking at row 5. I see the digits I'm missing are 2, 4, 8, 9. It's not immediately obvious to me anything cool that I could do with that. Except here, you know, these are 4, 8, or 9. So this is either 8 or 9. It's not quite giving me anything useful that I can see yet. So I'm going to go back to letters, I think, and see if I can get anything good from the letters. So this O is kind of intriguing. It's shaded, so it's got to be, but you know, this O, the problem is I don't know what it's next to, so it really could be just about anything, but it has to be fittable on one of these. So actually I'm not sure that's, maybe G would be better, because G has to be one of those spots, and G is not 1, 2, or 6. Actually, what letter is 3? So sorry, I'm going back and forth a lot, trying to think through what different things could be, like what each letter could correspond to, because I've got 3 of the letters tied down. So I've got 3, 4, 5, 7, 8, 9. What could those be? So 9 is interesting because it's either B, U, L, or Y. It can't be O because that Knight's move again. 3 I guess 3 could be just about anything. 4 has to be either O or any of these. No, it can't be G. Okay, so I'm going to look at the repeat letters. I'm going to look at the O's. What can O be? Can't be 1, can't be 2. It could be 3, could be 4 or 5. Is this too many? Or 8 or 9? No, it can't be 9. Can it be 8? It could be 8, I suppose. Ooh, okay, that's not so exciting. I'm going to erase that. That is not so good. Okay, let's go back to shading. Where do the 2's go? So, what 2's do I have left? Only this box is really left. So where can my 2 go in box 6? It's either one of these, but it can't be this one because it's shaded and not next to one of the ones. Or it can be any of those. It can't be here because that's a nice move from a 2. I almost don't want to. Actually, so I'm going to pencil mark this in for a second. This one actually can't be a 2. But it's a little hard to see. So why can't this be a 2? Actually, no, much easier, sorry. 2's, we kind of have an X-wing. 2's are in this pattern here. So one of the 2's in row 4 is in box 4. One of the 2's I've got 2 2's to play with in boxes 4 and 5. One of them is in row 4, one of them is in row 6. So neither of these can be a 2 because the 2 in row 6 is either in box 4 or 5. So that's my 2. This is 4, 8, or 9. Yeah, none of those really give me much information to go on. That's not 2. This is 2. Are my 2's done? No, I've got this X-wing of 2's left as well. Okay, X-wing of 2's and X-wings of 1's. Everything else is done. Okay, so let's see where the 3's are. 3's here. So I've got these 2 here, which means 3 is in one of those 2. It can't be here because that's adjacent to the 2 and not highlighted. It can't be in the middle because of this set here. So that means, well, I already knew it wasn't G. Where is it here? It can't be U because that's adjacent to it too. It can't be here. Actually, oh, okay, that's great. So U is, or sorry, that's even better. So the 3's in box 2 and 8 are known. This has to be the 3. We'll start in box 8. So where is the 3 in box 8? It can't be here because they're adjacent to the 2 and unhighlighted. It can't be here because of this pencil mark. It can't be in either of those because they're shaded and not adjacent to the 2. So the 3 is here. Now I can go back to box 2. This 3 takes up column 6. These 3's take up column 5. So this 3 is here. And now I know, wait, do I know this? Yes, now I know that 3 is O because it's the only letter it can be, right? So if I look back at the letters, what letter is 3? And actually, from now I'm going to do a little shortcut. All the letters are either in this row or this row, right? Because there are a couple, the only letters that aren't here are this G, which is repeated down here, and this O, which is repeated right here. So if I look through those columns, I can figure out what is kind of like all the possible letters. So where could the 3 be? It can't be B because of this 3. It can't be any of these because of this 3. It can't be Y because of the same 3, the next move constraint. So the only place the 3 could go is in O. And that gets rid of this. So I know where the 3 is, and therefore I know where the 2 is because this 3 is unshaded. And that disintegrates this 1-2 pair. Oops, and that gets rid of that one, that unknown 1. So we are now, I think we're almost done. So we've got our 1's done, we've got our 2's done, our 3's actually done, not quite. So can I finish the 3's? 3's in one of those 2 spots, and the shading lines up correctly. 3 is in one of those 2 spots, and that lines up correctly. But that is going to give us a 3 in box 9, which will have to be here because I've got this row of 3's, this row of 3's, and those columns of 3's. So I'm going to pencil mark that and then call that 3. So my 3's are almost done. I've got this 2 sets of 2 3's. Do I want to do letters or shading? I think between the two, it's going to go fairly quickly. Or do I just want to do some Sudoku? So here I've got column 5 is almost done. 1, 2, 3. I need a 4. I need a 7 and an 8. This can't be 4 because it's a shaded cell next to a 3. So that actually tells me G is not 4, which might be, well, I didn't do that already actually. So one of those is a 4. Oh, that actually means that's not a 4. Okay, so 4 has to be in one of those two cells. This cell here sees both, right? It sees this one by being the same box. It sees this one by being a knight's move away, so this can't be 4. I have this 8-9 pair, and there's a 4 there. Wow. I'm not sure that was intended, but I will take it. It's not that hard. It's a 3-star puzzle. That's probably was intended. So now the 4 in box 7 can't be here, because if this is the 4, the 3 would be over here, and this would be shaded, so that would not work. So my 4 is here. Does that help me? So what letter is 4? So 4 can't be U, it can't be G, it can't be B. So it's either L or Y. Interesting. Where does the 4 go? If 4 is Y, then the 4 is the 4, that just works, I think. If the 4s are L, no, 4 can't be L because L is shaded and not adjacent to its 3. So Y is 4. And now I can probably fill in most of the 4s for one of these two. So, well, I can just see right here, it's not this 4. So this is just normal Sudoku, filling in where the 4s could go. So I've got this pattern here. 4 cannot go in the top left of box 5 because that's shaded and not adjacent to its 3. So that completes the 4s. Let's see. I'm tempted to do the letters, but I kind of think I can just do shading from here on out. So let's look at 5s. The 5 in, okay, so actually this is a 3-5 pair. That's interesting. So I was going through, I was just kind of starting at the bottom and going left. Where could the 5s go? Box 4 wasn't so interesting. It could be anywhere in the top. It could be anywhere, right? Any of these, the shading is appropriate, so the 5 could go any of those. I guess it could go there because of this 5. But I know that 5 becomes a 3-5 pair here because 5 can't go in this cell because it's not next to the 4 and shaded. Same thing here. And it can't be in the bottom middle because that's not shaded and next to the 4. So one of these is 5. We knew one of them was 3 already. So that's a 3-5 pair. And actually, as I was explaining that, I saw that, looking at where the 5s could be here, where does 5 go in box 2? I was looking up here. Well, this is just a straightforward anti-knight. 5 clearly is in one of those. It's not the G because of this G. And it's not here because of knight's move and also the shading constraint. So 5 is in the top right corner of box 2. And now, where does 5 go in box 1? Well, it can't go here because that's unshaded next to the 4, so it's in one of those two. That's not so interesting. Oh, okay, where does 5 go in box 8? By knight's move, it can't be any of those, and normal Sudoku, so the 5 has to go here. Where does the 5 go in box 9? I've got the 5 in row 8, I've got the 5 in row 9, so 5 has to go here. The 5 then has to be in one of those two, but it can't be here because of the knight's move again, so that's not a 5, that is the 5, and now this is the 5-6 pair, but I know where it is because of this 5, so that's a 6 and a 5. That gets rid of that 5, which means B is 5, and I could have done that ago because of this 5 looking at these. And now from here, I know that the 5 has to be in one of those two because of knight's move. 5 can't be in any of those, so 5 is one of these. 5 can't be the lower because it's unshaded next to the 4. So there's the 5, that disambiguates my 3-5. Yeah, and we are basically done. This 3, just normal Sudoku, can't be there, so that's my 3. Let's see what's left here. 1, 2, 3, 4, 5. So this is 7 or 8. I'll fill that in. This can't be 7 because it is shaded and not next to its 6. So that's the 8, that's the 7. That means G is 8. And by knight's move, that means this is now 9, and that's 8. Here we've got a 7-9 pair. I see the 9 here. That tells me which is which. This row is basically done. The only thing missing is a 6, and the shading is correct. I have 7 and 9 here. This can't be 9, so it has to be 7 by the shading rule. Let's see, what's in this? This is all just basically done. I'm just filling in the Sudoku. The only missing thing in this row is 8. The thing missing, again, we have a 7, 9 missing here. This can't be 7 because it's unshaded and next to the 6, so that tells me which way the 7, 9 goes. We've got 8 and 9 missing here. This can't be 8 because it's next to the 7 and unshaded, so that's where my 8, 9 goes. And we have 6, 7, 8 here. Let's see, this can't be 8, so it's 6 or 7. It can't be 7 because it's not next to the 6 and shaded, so that has to be 6. Here I've got 7, 8. Let's see, by knight's move and by normal Sudoku, this can't be 7, so that's the 8. Here I've got a 7, 8, 9. By knight's move, it has to be 7. We have 8, 9. 8 is here, 9, 8. What's missing from this row is a 6. What I've left here, 7, 8, 9. By knight's move and 8, that's a 7. Here I've got 8, 9. This can't be 9 because it would be next to an 8, so that's the 9, and that's the 8. The 8 will be unshaded. Great. 1, 2, 3, 4, 5, 6. This is 6, 7, or 9. We have 7, 9 here, so that's the 6. We've got 7, 9 left over. 7 is here, so we've got a 9, 7, and we've finished. This is 40 minutes, but it was open for a little bit. Hopefully it didn't actually take that long. I'll look at the timestamp in a second. But that was the puzzle. I really enjoyed it. Thanks, Abdul the Killer, for posting it. And hopefully I'll make another one of these in a bit. All right, bye.